Hi, in this tutorial we are going to look at the basic layout and some of the fundamental functions of the render module. For this tutorial we have set up a simple bipolar shell nebula with a linear expansion law. This has been rendered in here. It has an enhanced density at the equator, which decreases outwards. The first thing that we see is in the render module are two images. This is on the left we have the rendered image of the object as it is modeled in structure. On the right we have the position velocity diagram with the horizontal axis being velocity in kilometers per second and the vertical axis is the position along the spectrographic slit. This group of two images is what we call an image group, and for the properties of such a group we have a particular properties panel on the right, and here we can set whether this is going to be rendered or not. And below this rendering tick mark we have some slit properties such as its position in horizontal X or the Y, its width and height in the current units, which in this example is set to meters. The position angle is historical and is not used at this time. And we can also select to save the slits in images that we can save, and we will look at this later, whether we want to see or not the slit while we are working. We can change its color. Like so. And the second part of the properties refers to the velocity in the PV diagram. Here the center velocity can be set. Then we have a range, the range that is covered by the whole image, so from the beginning to the end, and the current cursor velocity. Note that we have a cursor that can be dragged around if the move button is activated. Note also that there's a marking in the spectrographic slit in the image which shows the position of the cursor in the PV diagram. So we can easily check whether a feature in the PV diagram corresponds to a feature seen in the image. The cursor Y position is also given, and the resolution of the in kilometers per second with which the horizontal axis of the position velocity diagram is convolved. If we set that to some higher values such as 10, then or higher, then the image will be smoothed out. This is the full width half maximum width of the Gaussian beam with which it is convolved. Now, something very useful is that we can have more than one of these groups. The first group is the primary group, which cannot be deleted. But we can add secondary groups by clicking on the plus button at the top. And now we have a second group. We can give it a title, 2, for example, which then shows here. We can switch back and forth between these two by clicking on the monitor icons at the top. We can see them both at the same time by clicking using tile, clicking on the tile button. This is useful if you have several observations at different positions for the slit. For example, like now I can move the slit and then render such that I have two different position velocity diagrams. In the top case, I have selected Save Slit, which makes the slit permanent. Let's re-render to get rid of that. And each of these groups, when I select the group, I can give them different parameters. For example, the range and velocity can be different for both of them. Let's say I want to see this normally. Then I click on this button, Restore button. You can go back and forth. Some of the parameters, like the image parameters, the camera parameters, sorry, which includes the inclination, are the same, or the position angle, such that we can look at parallel slits only at this time. Okay, now that we have more than one group, if we want to have the same parameters in the second group as we have in the first group, then we can select the first group, click on this Copy Group Properties to Clipboard button, then select the second group and paste them using the second button. Now we have the same parameters for the slit, color and position, size, everything. Now we can move it and re-render. Okay, thank you.